Okay, so it's my pleasure to invite Dr. Eva Chin, Executive Director of Solve FSHD, to the stage where she will give an introduction to our $10 million FSHD bonus prize. Thank you.
Thank you very much. Thank you for the invitation to come. Okay. Number one, fabulous to be here at the ARDD meeting. Fascinating to be back in Denmark and in Copenhagen, especially at such a distinguished institution. I think a lot of those of us that started in the muscle biology field recognize the great work that's come out of Copenhagen University in muscle physiology, biochemistry, and performance. So thrilled to be here. One small anecdotal story then, Jamie. A year ago, you got a cold call. About 3 years ago, I got a cold call about a rather unique opportunity. I was actually living in Denmark at the time, over in Jutland, working for a startup company, NMD Pharma, but looking to move back to North America because I had an aspiring ice hockey player and a little bit better hockey over in Canada. So we were open to the opportunity, and so I took the offer to become the first executive director of Solve FSHD. We heard our founder speak earlier. Chip Wilson is our founder. He didn't mention specifically, but he does have FSHD. And so he was inspired to commit $100 million to what he initially wanted was a cure for FSHD by 2027. And I think those of us that work in therapeutics, we kind of cringe. It's really hard to cure a disease, and how do you define that, and how do you make that happen in 6 years? So we have redefined a solve for FSHD, and we're about to do more of a press release on that. But really what we hope to do as an organization is to increase the pipeline of therapeutics out there for FSHD patients so that all of them at least have access to an experimental therapy, and hopefully eventually will be on a therapeutic that helps to improve their debilitating loss of muscle function. So you can go to our website as well. We have more anecdotal stories from both Chip and our other board member, Neil Camarda, who has FSHD. We are committed to funding various activities, both academic-based research that KOLs do to try to identify better predictive biomarkers, to develop, I think, what are better, more innovative endpoints, so we'll speak to briefly. But also we invest in early and mid-stage clinical trials. We'd like to fund clinical trials. We really want to accelerate getting to a therapeutic for FSHD. And my goal here is to tell you a little bit more about FSHD itself and hopefully inspire more of the people at this conference to consider going after the FSHD bonus prize. So FSHD, as Chip mentioned, it's facioscapulohumeral muscular dystrophy. The unique part is that it mostly affects face and upper body. Somebody like Chip, he's still pretty fit. As a former athlete and national level swimmer, he did Mount Kilimanjaro about a year ago. He said it almost killed him, but he did it. But he can't reach his arms above his head, and he stopped playing squash when people used to lob the ball over his head and he couldn't hit it. So upper body, different muscles affected, but largely in the upper body. Legs eventually are affected, particularly the tibialis anterior. Again, why certain muscles are affected when is largely unknown. But it eventually does progress to lower body, does affect mobility, and does lead to loss of ambulation and really requiring a wheelchair. We understand a fair bit about the underlying causes of it. It has been identified. The genetic cause is a reduction in the repeats of the D4Z4 region on the 4th chromosome. I have a little bit more I'll show you about this in a short video clip. So normally you would have more than 10 repeats. FSHD is identified by having 10 or fewer repeats of the D4Z4 region. It's also associated with hypomethylation. So a second form of FSHD, FSHD2, can be caused by mutations in various methylating genes like SMCHD1, DNMT3B, and LRIF1. And early on when I was at Solve FSHD and we were trying to decide how much do we support the longevity part of XPRIZE versus the FSHD bonus prize, we had really great conversations with leaders in the field. The fact that this is an epigenetically modified disease, affects the chromatin remodeling structure, there's a lot of overlapping interests, but I think I don't have to convince this group that FSHD is not aging and aging is not FSHD, and that's why we decided to separate those prizes. Certainly there's correlations between them, but we want to identify people that specifically can target FSHD to come up with the treatment. A little bit more about FSHD. The hallmark delineation of FSHD now is identified on MRI imaging, where you initially have regions of the muscle that are stir positive, showing areas of inflammation, and generally those areas then progress to being the areas of fatty infiltration as identified by the T1 signal on MRI imaging. So there is this disease progression, but there is heterogeneity between muscles. There's also heterogeneity within a muscle. A hallmark of histopathology, which is the way muscle diseases used to be diagnosed, is that you do have areas of inflammatory cell infiltration. You also have areas of immune cell infiltration, largely CD8 positive and CD4 positive cells, and they're particularly found in the perivascular region, which is an interesting part of the disease I think is overlooked and underappreciated. So there's heterogeneity between muscles, there's heterogeneity within muscles, but I will point out that I think a lot of the features of FSHD does have overlapping aspects related to aging, especially the fat infiltration within the muscle. So it's not subcutaneous fat, it's the fat infiltration in the muscle. So I'm going to tell you a little bit more about FSHD via a video that we recently had made, and I'm going to let you listen to this.
Facioscapulohumeral muscular dystrophy, FSHD, is one of the most common muscular dystrophies, affecting 1 in 8,000 individuals worldwide with no current cure. FSHD is a debilitating disease characterized by progressive atrophy and weakness of certain muscle groups, often resulting in severe movement restrictions and impaired recovery from muscle injury. FSHD is associated with genetic and epigenetic modifications, affecting primarily the expression of the DUX4 gene. DUX4 encodes a transcription factor, a type of protein that can bind DNA and regulate gene expression. While DUX4 activity is essential during embryonic development, it later undergoes epigenetic silencing. Aberrant activation of DUX4 during or after development hinders the expression of genes involved in muscle development and muscle repair after injury, leading to FSHD. The DUX4 gene is located within a region of high repetition on chromosome 4, where the DNA is under strong epigenetic regulation, kept in a tightly packed conformation that prevents gene expression. Whilst healthy individuals hold 10 to 100 copies of a repeated genomic sequence, D4Z4, FSHD1 patients carry chromosomal deletions, which allow the DNA to exist in a relaxed conformation, favoring the production of RNA and protein. A different disease variation, FSHD2, occurs due to mutations that affect the function of methylases, proteins that maintain epigenetic silencing through the addition of methylation signals. This ultimately has the same disease-permissive effect, resulting from DUX4 gene and protein expression. FSHD is a complex and debilitating genetic disease. Continued investigation is needed to widen the disease knowledge and develop appropriate therapeutics. Solve FSHD is a venture philanthropic organization dedicated to finding a solution that can slow down or stop disease progression, resulting in increased muscle strength and function, leading to improved quality of life for those living with FSHD. $100 million has been committed by Solve FSHD's founder, Chip Wilson, who also suffers from the disease, to help discover a cure. For more information, please visit our website at solvefshd.com.
Okay, just to let you know, you are the first to see that video. We previously had not released it. Whoops, I wanted to go backwards. I went the wrong way. A few follow-up points from that video. So a fair bit of work has been done understanding DUX4 as the aberrantly expressed transcription factor causing apoptotic changes It does have effects in muscle. If you overexpress it in muscle, you impair muscle regeneration. We know the histopathology, but there's a big black box space in between, and there's a lot that's not understood. And although I'm a hardcore muscle biologist, I think there are other cell types that could be impaired. Currently, a lot of the therapeutics focus has been on silencing DUX4. Some companies are going after modifying the methylation state, but I think there's a lot more within that D4, Z4 region and a lot more of the biology we don't understand. And I certainly would inspire people in this group to also consider looking at FSHD, understanding the pathophysiology, and considering other ways to target the disease. A little bit more then about the FSHD bonus prize. As Jamie mentioned, there will be an interim prize at the first milestone. We will have 8 prizes of $250,000 at the first milestone, and then the final prize will be the $8 million. A little bit more detail, again, we are wanting to see a change at the muscle level based on a reduction of the fat infiltration, or a circulating biomarker that changed. That's an area of intense investigation, and the biomarkers really are just being reported on now. But we want to know it affects the biology of the disease in combination with improvement in 3 of those measures of muscle function. Many of those measures of muscle function are quite familiar to people that work on age-related frailty or sarcopenia. But I'll also mention the additional ones that have been identified and well characterized in the FSHD community are the FSHD-COM. I have one more slide on that. Reachable workspace is a new endpoint that's been identified and that regulators are accepting with the leading companies in clinical trials. But we also, I'm a firm believer that we need some more innovation in how we look at clinical outcomes in FSHD. And I think this is the perfect audience to, again, try to stimulate and inspire some innovation in how we measure outcomes in FSHD. Quickly then, this is the FSHD-COM. It's a lot to read, but you'll recognize a lot of those outcomes, leg function, trunk function, the timed up and go. These are all components of a composite score that have been characterized in FSHD. The paper there by Eichinger et al., that's a PT that's worked on FSHD out of Robbie Tawil's lab at the University of Rochester. So Dr. Tawil at Rochester, although he recently retired, he's trained a lot of other scientists, and Jeff Statland at Kansas University are 2 of the leaders in the US, and they've done a lot of work characterizing the natural history of disease progression in FSHD, which is an important thing to understand, at least for the global change over across subjects, although I will say I certainly agree that individualized outcomes are what we need for a disease as heterogeneous as FSHD. A little bit about reachable workspace, and I've taken this from Fulcrum Therapeutics' recent corporate presentation. They have introduced this endpoint measure of reaching in the 5 different quadrants. It previously has been used in Duchenne muscular dystrophy for an outcome measure of boys with muscular dystrophy. Number 1, because it measures function of the upper limbs. Number 2, because it does seem to show ability to sense or predict or pick up a difference with treatment. So on the right is shown the natural history progression of about 3% decline in the reachable workspace over a year, but Fulcrum, with their leading molecule losmapimod, has shown an attenuation of that difference in less than a year. Fulcrum is probably a few months out from releasing phase 3 data that could change the landscape of FSHD, but we do believe that we will in the future need combinatorial therapies, even on top of the lead companies in the field. And then just to mention, the FSHD community is a well-organized community of various global advocacy organizations, so the patient advocacy organizations in the US, Europe, the Netherlands is particularly strong, Brazil, Australia, really internationally. And then the US-based and US-led Clinical Trial Research Network, or CTRN, which we are one of the funders of, has sites globally, as you can see. So there are the experts. So if you go to the CTRN website, you can find if there's a local clinician scientist that you could work with if you're interested in the FSHD bonus prize. So in summary, I just want to say that, FSHD is a relatively well-characterized disease biology, but with some definite gaps and need for innovation and additional insight from additional researchers that we would love to have come into the field. It does have a tractable target with one known transcription factor that results and is associated with much of the disease pathology. Has an engaged patient community and well-organized clinical trial research network. Potential for rapid clinical development based on the known changes in the disease biology and natural history. More recently, one of the leading biotech companies has shown a difference in DUX4-dependent gene expression even after 3 months of treatment. So we do believe that there are sensitive markers of change in the muscle pathology or muscle molecular biology earlier than 1 year. And it's a sizable commercial opportunity, certainly for companies that are working in the muscle-related or age-related disease space. It's definitely an ideal commercial opportunity to also go into FSHD. So with that, I thank you for your attention, and I'll be around for the rest of the day in the conference if you have any additional questions.